This lecture, we will talk about properties of exponents. Before we do the properties of exponents, we want to see examples. Look, when we have a 2 times 2 times 2, 3 2's here, then we write 2 cubed, and this 3 is called exponent. So you know 2 times 2 times 2, which is 8. The common mistake is 2 cubed. You use 2 times 3, you get 6, which is wrong. So I put right here, it's not 6, it should be 8. Okay? Now, another example is negative 2 times negative 2 times negative 2, which is negative 2 cubed. This 3 actually acts on the whole thing, negative 2. That's why we have a parenthesis right here. So you see 3 negative 2 together is negative 8. Now, 2 to the 4th is actually 4 2's times each other. So we have a 16 instead of 8. All right. And then negative 2, negative 2, negative 2, negative 2, 4 times. So you write parenthesis negative 2 to the 4th, which is positive 16. Because the number of negatives is even, so you get positive. Here the number of negatives are odd, so you get negative. The remark right here is that negative 2 to the 4th is actually negative. This 4 acts only on 2, not on this negative sign. So I put the parentheses right here. So then you can see 2 to the 4th, which is 16, and then you have a negative in front of it. So those two are totally different. Okay? One is 4x on negative 2, another is 4 only x on 2, not negative. So you have to find out 2 to the 4th, which is 16, and put negative in front of it. Now, let's see some properties of exponents. You can see right here, 2 cubed times 2 to the 5th is actually 3 2's times 5 2's. So you can count 3 2's, 5 2's together is 8 2's. So that's 2 to the 8th, which is 256. Where is this 8 from? That's 3 plus 5. Okay? So you can see when you do the multiplication about exponents with the same base, 2 here, so you basically do is add exponents. 3 plus 5 is 8. You add. So this kind of rule is called product rule. Now, let's look at 3 to the 4th times 3 to the 7th. Based on this rule here, you do is 4 plus 7, which gives you 11. By using your calculator, you write is 3, arrow pointing up, and then 11. So you have the answer is 177,147. Okay? So here is 7. Huh? Here is 7. Now, you may try the following yourself. 4 cubed times 4 to the 5th. What is the steps you should get? Put here. And then this is the final answer you should have. Try this one. The same. Okay? Now, let's look at another example. 2 to the 5th divided by 2 cubed. You know 2 to the 5th, again, is there are 5 2's upstairs, 3 2's downstairs. And then you know 1 times any number is that number, so I put 1 in front of it. Now you have a 3 2's upstairs, 3 2's downstairs, you can cancel that. So you have actually is 2 times 2 upstairs, downstairs, you have a 1 left over there. Instead of 0, not 0, okay? Because 1 times this number. So you have a 1 over there. And then you can see that upstairs is 2 times 2, which is 2 cubed. 2 squared. 2 squared. And which is 4. Where is this 2 from? Squared. 2 from is what? 5 minus 3, which is 2. 5 minus 3, which is 2. Okay? So, for division, you do is you use the exponent for numerator minus exponent of the denominator. Alright? That would be, we call this is the quotient rule. Quotient rule. Now you may try this one yourself. 3 to the 7th over 3 to the 5th equals what you should put here. Based on this rule, should be which number minus which. Put here. You should have the final answer is 9. Alright? When you do those things, remember, you don't do 3 times 2 or 2 times 3. You do is what? 2 to 2, here is 8. Alright? Okay. Now, let's see another rule. This would be our second rule, quotient rule. Let's see the third rule. Look at this example first. 3 cubed divided by 2 to the 5th equals 2, based on this rule, is 3 minus 5, which is negative 2 for the exponent. So 2 to the negative 2. That's on one hand, based on this rule. On the other hand, you can see 2 cubed is 2 to 2 3 times upstairs. Of course, you can put 1 here, times 1. Because 1 times 8 is 8. So you can put 1 all the time. Downstairs is 2 to the 5th. That's 5 2's downstairs. So again, you can cancel 3 2 upstairs with the 3 2 downstairs. You have is 1 over 2 squared, because 2 times 2 is 2 squared, which is 1/4. So you can see here is 2 to the negative 2, and then equals 1 over 2 to the negative 2, which is actually 2 squared, 1 over 2 squared. So this negative sign basically gives us is that you put 1 as a numerator, and then divided by 2 squared. That is 1/4. Okay, 1/4. Now, from here we can derive the third rule, which is negative exponent rule, is a number to the negative exponent equals 1. You always have a 1 upstairs, and downstairs is just x to that n without negative sign. So this is another example. 3 to the negative 5th equals, based on this rule, is 1 upstairs, and write negative 5 as positive 5, 3 to the 5th. Okay? 3 to the 5th, by using your calculator, 3 arrow pointing up to the 5 is going to be 243. So the final answer is 1 over 243. That's for this one. You may try the following yourself. 4 to the negative 6th equals what? Fill in the blank and then get, this should be the answer you have. 1 over 4096. Now, before we go to this rule, let's start with this example. 2 cubed divided by 2 cubed, you can handle that by two ways. One is by this rule, quotient rule, that's exponent minus exponent. So you have a 2 to the 0. That's on one hand. You don't know what 2 to the 0 is. But on the other hand, you can see 2 cubed is 2 to 2 upstairs. And then 2 to 2 downstairs, 3 2s. So you have a 1 times this 2 to 2 upstairs and 1 times 2 to 2 downstairs. And this is going, you can cancel 2 upstairs, downstairs, upstairs, downstairs. There are 3 2s, and you get 1. This basically tells us that 2 to the 0 is 1. So a non-zero number to the 0 is not 0, is 1. Okay? So that means in future, any x, if x is not 0, then to the 0 you should have a 1. Okay? Not 0. Here are more examples. 4 to the 0 is 1. Negative 5 to the 0 is 1. 100 to the 0 is 1. 0 to the 0, because here is 0 base, so it's not defined. Be careful, okay? X cannot be 0. All right. Now, this is our fourth rule, which is called zero exponent rule. Let's look at the fifth one, this one. Before we derive this one, look at this example. This is 2 to the 4th and then cubed. This exponent 3 tells us that 2 to the 4th repeat 3 times. So 2 to the 4th, 2 to the 4th, 2 to the 4th, 3 times because of this 3. But on the other hand, 2 to the 4th can be written as 2 times 2 times 2 times 2, 4 times. And this one, 2 to the 4th, can be written as that, 2 times 2 times 2 times 2, 4 2s. And so is this case, 2 to the 4th is that. How many 2s? 4, 4, 4, 12, 2 to the 12th. So there are 12 2s. By using your calculator, in your calculator, 2 arrow and then 12. This is going to be 4096. Where is this 12 from? This 12 is actually 4 times 3 gives you 12. So in future, if you have an a to the m, then to the m, instead of adding m plus m and n, you should do is m times n. Okay? Now, this is the example. 3 to the 4th to the 5th. You do then is 3 to the 4 times 5 as your exponent, which is 20. 3 to the 20th is equal to 2 by using your calculator. Okay? You may write here that in your calculator, okay, 2 to the 20th. This number is big. 1,048,576. It's very big. It's not 60, all right? It's not 3 times 20. Try the following yourself based on this example. 2 to the 5th to the 6th. What you should get is this number, but put some middle steps right here. Now, let's see more examples. This example, those two examples, following examples are very comprehensive. You need to understand product rule, quotient rule, negative exponent and zero exponent rule, and also this one. okay, to do the following things. Let me do this one, the first one for you. 2 times x cubed times times y to the negative 2, the whole thing cubed. You know, 2 is 2 to the first. The exponent is 1. I write in this way is because by the rule right here, power rule, right here is that 1 times 3 gives you 3. 3 times 3 for the x, base x, gives you, exponent is 9. For the base y, negative 2 times 3 gives you negative 6. So, 2 cubed is 8. X to the 9th, you copy it. Where does this y to the negative 6 go? You know what? Negative 5, you basically flip it. You see, put 1 here and 3 to the 5th. And here is the same thing. Y to the negative 6, you flip this y down here and put the exponent as positive 6 instead of negative 6. Then you are done right here. Okay? So, try the following yourself, this one. This should be the answer you get. Okay? This should be the answer you get. So follow this one. Now let's look at this one. This one looks very hard. So here, based on the power rule, you do is a to the negative 4th and then divided by b squared, whole thing squared. By this rule, power rule, you have a to the negative 4 times 2, which is negative 8. B squared, here the exponent is 2, you need to times this 2, you have a 4 right here. Now, again, here a to the negative 8, exponent is negative, so you flip it down and put the positive exponent 8. So here you see b to the 4th was downstairs, but here a to the negative 8, you see you flip it down, flip a down here and put exponent. This is the note. A to the negative 8 equals that. It's because of that. Or example over there. Now, the last 2 lines are even harder. Look, this is 1 over b to the negative 4th. You know, 1 over b to the negative 4th is 1 over b to the 4th. Okay? You rewrite b to the negative 4th as 1 over b to the 4th. Similarly like that. The only difference is the b to the negative 4th is downstairs. So you keep it downstairs first. Now, 1 divided by 1 divided by b to the 4th can be written like this. Okay? This is main fractional bar, so divided. This one means division. And then by the rule of the division for fractional numbers, divided, you flip this number, b to the 4th up, 1 down, changing this division into multiplication. So you have equals b to the 4th. Because 1 times b to the 4th is b to the 4th. And then divided by 1, you can simply don't need to write 1. So that's b to the 4th. Look at the answer. 1 over b to the negative 4th equals b to the 4th. Okay? So basically in this case, if negative sign is, for b to the negative 4 to the negative 4, you can flip this b to the top and change this negative sign to positive. So it's basically b to the negative to the positive 4. Now, that's the example we needed to use that. Again, a to the negative 4 divided by b squared, and then to the negative 2. You do is a to the negative 4 times negative 2 by this rule. Negative 4 times negative 2, you have a positive 8. So numerator is a to the positive 8, because negative 2 times negative 4 is positive 8. Downstairs is b squared, 10 to the negative 2. You know, b, you keep it. 2 times negative 2, you have a negative 4. Now you can see b to the negative 4, b to the negative 4, those two are downstairs. Okay, based on the previous result, you flip it to the top. Okay? You keep a to the 8th, and then keep this b to the negative 4th is going to be changed to b to the 4th, and it's upstairs already, like that. Okay, try this one yourself. Try this one yourself. And here is x to the 5th divided by y to the negative 2, and then to the negative 3. This is the final answer. 1 divided by x to the 15th times y to the 6th. That's the final answer. So fill in the middle steps. Here we have discussed 1, 2, 3, 4, 5 properties and some comprehensive examples. Try some exercise yourself. Go to the internet or find out similar examples in the book. Good luck with this section, which is very hard. I'll see you next time.